Good evening, ladies and gentlemen. A very warm welcome to all our participants, dignitaries, our esteemed speaker, and industry representatives to the online event on demystifying application of artificial intelligence and emerging technologies organized by the IMC Chamber of Commerce and Industry. All participants will be muted to avoid any disturbances during the course of the session. To consume less bandwidth and clarity, you are requested to stop video streaming at your end. Kindly post all your relevant queries in the chat section so that the same can be addressed as time permits. The most important, do send us your feedback on the link provided in the chat section so that we can keep improving our events based on your valuable suggestions. As we begin the session, may I request Mr. Juzer Khorakiwala, President, IMC Chamber of Commerce and Industry, to present the welcome address. Over to you, Mr. Khorakiwala.
Thank you, Selby, and good afternoon to all the participants. On behalf of the IMC Chamber of Commerce and Industry, it gives me immense pleasure to welcome all the distinguished guests, our esteemed speaker, Dr. Rajesh Save, co-founder, Provis.ai, to the online session on demystifying application for artificial intelligence and emerging technologies. I'll just preface my remarks by saying that recently I was reading a book on future is faster than you think. I'm actually started reading it, and then one realizes that technology in the entire ecosystem is such that it comes from connecting various dots in the technology field, from material sciences to artificial intelligence to machine learning to digital applications. All these somehow come together in some form or the other and give you a new product. Like when I was reading this book, I was amazed to realize that they are planning, that United States is planning to have the Uber air services commercialized sometime in 2024 in Chicago. It will be commercial Uber air taxis. Now, this is a huge leap forward in terms of mobility, and this takes into account all kinds of technologies, including artificial intelligence and all various technologies. So I think technology is such a animal, if I were to use that word, that how it affects your lifestyle and your life, you never know until it comes as a final product or a service to you. So I think this session today afternoon on demystifying application of artificial intelligence in emerging technologies, I think will dwell on these issues during this session on machine learning, artificial intelligence, and robotic process automations. So with this few initial remarks, before I end, I'd like to brief you about the Indian Merchants Chamber of Commerce, which has a rich legacy of over 100 years of since it was founded. It has a membership base of almost 5,000 members and almost 150 trade associations who are associated with IMC. Over the years, a galaxy of leaders, both Indian and international, including presidents and prime ministers, have adorned our chamber with their visits. So with these few words, I'll now request our main speaker, Dr. Rajesh Save, to initiate the proceedings. Thank you.
Thank you, Mr. Khorakiwala. I now request Mr. Uday Sanghani, member, IMC Digital Technology Committee, to present the introductory address. Over to you, Mr. Sanghani.
Yeah, thank you very much, Mr. Khorakiwala, for your insights, extremely enlightening. I think this session comes at the most appropriate time, given that there has been a huge focus in the budget announcements yesterday, and across the board, almost in every single area of the business, the finance minister spoke about introducing digital concepts, emerging technologies, and a lot of boost to embracing new digital technologies into your business. What I have out here is just a couple of slides, which I'm sure most of you on this call will be able to relate to. The last 2 years, all of our industries, whether you're in manufacturing or in services, have felt the impact differently. So if you look at your x-axis, we're talking about the revenues and we're talking about the profits and the margin on the y-axis. So over 150 C-level executives across the global 2000 enterprises were interviewed. And this is a research that came in from Horses for Sources. And what we see out here is that the valuation, the bubble indicates the valuation, the impact on the valuation of these different industries. So what you see out here, there has been a positive valuation, small to big, especially in areas of health, banking, financial services, life sciences, health pharma companies, insurance companies, whereas certainly travel and hospitality, consumer product, retail, we are talking about the brick and mortar organizations. Most of these have faced a whole lot of challenges, to really some of them survive, and some of them to really keep the trend going as they have been in the past few years. So the time has come, right? We talking about it. The time has come. The new dawn is to become a one office organization. You need to be a connected enterprise. You need to connect your front, middle, and back offices to deliver the one office by embracing new digital technologies. And when we talk about emerging technologies and new digital technologies, the what are the digital enablers, right, to make it a one office, to make it an integrated, seamless organization, so that you are able to have your legacy systems. A number of you have been functioning over the last so many years, and you've been using technologies over the years. Some of it is old technology, but you really want to now embrace the new digital technology. So integrating all of that is become imperative today in business. So what are the new technologies, right? We're talking about process automation. Mr. Khorakiwala referred to robotic process automation, bots. We're familiar with process automation. Artificial intelligence, right? We're going to demystify that for you today. We're going to get into the ABCs of what we mean by artificial intelligence. What is machine learning? What is cognitive solutioning? Why do you need to embrace these technologies into your business? Smart analytics, that's extremely important, right, for decision making. People are talking about moving or migrating to the cloud, right? Whether you are multi-cloud environment or it's hybrid, some of it is on-prem, some of it is migrated to the cloud. Why do you need to do it? Blockchain, we're talking a lot about blockchain. Of course, we won't cover the depths of blockchain today because we got another session coming up in the month, and Selvi will talk about it at the end of this particular session. But blockchain is another important technology that we are all intrigued by. And of course the edge computing, especially for the manufacturers. So all of this in the immediate, if you see, is going to bring in a lot of efficiency, productivity. But in the next 2 years, you have to, it's essential, it's going to become an essential part of your business operations. So it's no more creating business cases and then trying to evaluate whether you want to take the leap and move into these technologies. I think the time in a year would soon migrate into a zone where you will have to get it into your organization. So better now than later. And just here, these are some of the business cases, use cases, and we're going to get into a lot of use cases. So the session today is just smeared with a number of use cases. But just to tell you, if you talk about client specific, every single industry, there are multiple use cases. Or you're talking about enabling services that cut across agnostic of the sector, agnostic of your business, whether it's finance and accounting, whether it's your P2P, it's your R2R, right? Whether it's your three-way matching, whether it's your OCR, scanning all of your invoices, reconciling. So finance and accounting, huge number of opportunities there to automate customer service, your front office portals, your connection with your consumer, sales and marketing, human resources, procurement, IT help desk, you name it. And in every single area today, we have a number of use cases, and we are going to dwell upon some of them. So this session is going to demystify. We're going to get into the ABCs, and we're going to be having a number of case studies that we're going to talk about. So please feel free to post in your questions into the chat session, and we will cover it during the course of this session. In case we are not able to, then we will ensure that we send your responses back at the end of the session. Now, we are very fortunate that we have with us Dr. Rajesh Save, who's going to be leading this session for us. Dr. Save is the co-founder of the company Provits.ai. He's a consultant, and he has primarily been a consultant in the area of people analytics for globally reputed firms. He was the CHRO for Larsen and Toubro Infotech. He was the CHRO at Syntel Inc. Dr. Save has implemented machine learning algorithms for prescriptive and predictive analytics to address HR issues. So he's one individual, I believe I would like to introduce him, who is a people developer at heart, but is also a technocrat. Now that's a perfect combination to have for this particular session. He's a visiting faculty for people analytics and machine learning at the Narsi Monji Institute of Management Studies. He's also a member of the board of studies for IT at National Insurance Academy. And his specialties include talent analytics, data science, applied statistics, organization development, business simulation, psychometrics, HR strategy, and the people side of merger and acquisitions. He's also founder of the company Centroid Analytics. So without much ado, let me hand it over to Mr. Rajesh Save, Dr. Rajesh Save. Thank you.
Well, thank you so much, Uday. I think you've really blown it up so much, and that actually pressurizes, it puts a lot of pressure on me. But it's my pleasure, to be here with the August panel of the IMC office bearer. So thank you so much, Mr. Korakiwala, Sangani, and every other member of the IMC. It's my pleasure to be here, and as Mr. Sangani has already warned me that, in fact, later when he said, I'm going to count the number of jargons that you're going to say in this class. I mean, not class, it's basically this session. And then let me see how many jargons you speak. So you try and avoid as many jargons as possible, because obviously when it comes to demystifying, you have to actually make it as simple as possible that even a commoner should understand what exactly does it mean. And I'll try my level best to ensure that I would make it as simple as possible. Of course, it's an uphill task, but certainly I will give it a shot for sure. So let me share my screen before I start, just a second. So here we go. First of all, artificial intelligence. Now, it's such a global word. There are so many things which are covered by artificial intelligence, and one really wonders, what does it exactly mean? Because lately we've been hearing this word. Of course, we have been hearing a lot for the last few years, I must say. But if I have to just trace it back, how old is this word, artificial intelligence? More than 6 decades. It's probably late 50s, so the first time that they started talking of artificial intelligence, and after that, there have been waves and waves of AI. In fact, yes, Spielberg made a movie in 2002 called AI. And even then, so one wonders, why all of a sudden there's so much of buzz about this word, artificial intelligence, and the entire the world is talking of AI. All of a sudden, the last 5 years, what has happened differently? And the answer is, the computing power. It has multifolded. It has exponentially grown as Gordon Moore, the founder of Intel, and the co-chairman, the founder of Intel, had predicted. In fact, there's a Moore's law which basically said that every 18 months the computing power doubles up. Since 72, it's been doubling up, and the cloud. So the ability to store data, that has gone up very high, and that's the reason that probably we have reached here this point in time today. And I don't see any coming back now. AI has taken a couple of times beating. They call it the winters in AI's life, but I don't see any winter coming in now. I think it's going to be exponentially. Every year I keep on hearing, every month I'm hearing something different, something new. So that's basically. So on that note, let's start. And emerging technologies. Now one would wonder, what these emerging technologies are. Some of them probably you keep on hearing, you have been hearing about it, but the implementation and execution has not been there the way it should be. Blockchain, Mr. Sangani just spoke about blockchain. Now, blockchain essentially, it's been kind of referred with crypto. However, if some of the Estonia, for example, a country with meager population, they have implemented blockchain for their land records, right? So blockchain, unfortunately, has been very often spoken along with cryptos, but well, I think that's very sad, because blockchain has got terrific applications, and I'm sure you'll have a session on blockchain that's definite. So blockchain has been around for a while, but yeah, it still remains emerging. So there are quite a few technologies which will keep emerging for a while. So on that note, let's get going. Industry 4.0. I think when I was chatting with Mr. Sangani about this particular session, and he essentially referred that yes, most of our people who are going to be here for this session are going to be SMEs and MSMEs, and they would definitely look forward from manufacturing perspective. So I've ensured that this, of course, there are some other examples as well. There are a few other cases as well, but I have ensured that I have covered as much manufacturing as possible. And obviously, as our Prime Minister has been talking about it, we have been talking about Atmanirbhar and focus on manufacturing. So of course, services we have really done a lot, but I think manufacturing is something that we really need to do quite a few things. So if you have to see how the entire manufacturing as industry 1.0, 2.0 has grown quickly, it's 1784 way back when Stephenson's rocket, and we keep on talking about the industrial revolution and so on and so forth, right? So if you have to really kind of cut it across in terms of what exactly powered machines, that could be industry 1.0, 2.0, and 3.0 and 4.0. So basically, machines were powered by water and steam. That is the first time when industrial version, we all know about it, way back in 1780s, right? Sooner or later, in fact, as the electricity started kind of creeping in, steel and mass production happened. That's the time when the 2.0 happened. I'm sorry, there's a typo here. That 1784 is actually 1884. My sincere apologies for this, for the industrial revolution. So that's the third, and the fourth is basically about cyber systems. So that's the time when the entire 4.0 started. So let's talk about 4.0. What is powering? So those are the emerging technologies that are powering 4.0. That is something that we need to discuss a little further. So what is 4.0, if I may say so? So 4.0 is basically a new phase of industrial revolution that introduces intelligent networking. The word is very important, because networking of machines is going to be the future here on. It's been happening, and how does it happen? We will see a couple of case studies to that effect as well. But I think that is something which is going to be key thing for the future. So this intelligent networking of machines and processes for the industry that help of information and data, right? And of course, communication technology. So just to give you an example, at your home or even in the office or anywhere, of course, home is a little long shot. People have been talking about it, that you can operate your microwave ovens and your washing machines and your dishwashers from your office and so on and so forth. Of course, it is at more of a conceptual level, but there have been proof of concept POCs as well. But even otherwise, your conveyor belts and a lot of other things that on your shop floor are kind of operated by these connected machines. So if you look at how do they really operate these connected machines and how do they talk to each other, that's something which is basically, and there you must thank the entire cloud, because It is completely controlled through cloud. So there are sensors. In fact, there are two things, sensors and clouds. If I have to kind of completely demystify it, the information or the data, right, is collected through the machines and it is conveyed to the cloud. I just spoke about the storage capability, which has really helped us to push the entire AI revolution further. And this is where it counts a lot. 20 years ago, in fact, I remember when I started, I used to work for a company called Tata Unisys about 25 years ago. And that's the time when things like Sun Solaris, the servers were so important. Today, nobody talks of servers, right? Because, and that's the reason that it was so freakingly expensive. So that's one more thing that I want to talk about today towards the end of the session. That after all this that we hear, what is it? How much is it going to cost me? Right? I think that is the key question that we will discuss to the end of the session, because we talk of such a nebulous stuff, so many exotic technologies that we keep on chatting about. But can I really afford that? Because that's a big question, and that's going to be, cloud has the answer, but we'll talk about it a little later as we move further. So if just in case you have, in fact, there's another story which I'll start kind of narrating cases while in the flow. So there's this very famous case of Coke and Walmart. What happens is, and this is basically a supply chain distribution case. What happens is all the Coke trucks which are plying on the road, they're fitted by sensors. And what happens is the moment so there are the Coke cans are stored in racks in Walmart stores. So they keep on pulling the racks one after the other as they consume it, and the last rack, when it is pulled, the nearmost truck, wherever it is on the road, which is plying, the Coke truck gets a message that the last rack has been pulled, which means that they have a limited stock in a specific Walmart. And suddenly the driver would get the message. There is no human intervention except the fact that the driver would get the truck to the Walmart, and the entire thing is shifted. Everything is automated. Nobody places order. Nothing. Everything is driven by sensors and data flow. Okay. Obviously, yes. I mean, there is accounting and other things happen online as well. I don't have to talk about it, but that's how the entire. Yes, Nitin, IoT. So we're going to be talking a lot about IoT, Nitin. There are quite a few case studies on IoT. So likewise, I'm just mentioning one case study like that, but there are several case studies which mention about how IoT is used. So similarly, this is our the moment the person gets information from your handheld devices can talk to the cloud, and you can send the message and so on and so forth. So there are several things which are currently driven for the industry 4.0. Drones, right? In fact, I'll give you another case over here, how drones are effectively used. Very important. And this is amazing. This happened in New Orleans. Of course, New Orleans is known for the hurricanes which keep on hitting them every season, at least 1 or 2. 6 or 7 big hurricanes hit the US, but out of which a couple of them are generally disastrous, and they generally hit Louisiana and New Orleans and that area. What happened in this particular case, and this is very interesting, guys. What happened is, in this particular case, there's a very big insurance company in the US, and their earnings call was about 4 days or 5 days away, and that's the time that entire devastation of New Orleans happened. This company had a huge exposure in New Orleans, right? Because they had insured several houses and so on and so forth. So obviously, it was imperative for them to at least talk about what is happening in their earnings call, right? What exactly is going to be happening? You know what they did? Of course, that company didn't do it, but the IT partner they did. What they did is they sent drones, because you just couldn't have entered New Orleans at that point in time. It was water everywhere. So they just entered, sent drones. Several drones were sent, and millions pictures were taken of the devastated houses and so on and so forth. All these pictures. Now, when you look at data primarily is of two types, right? Structured and unstructured. By the way, by and large, if you look at the kind of data that is generated every day, there are trillion petabytes of data is generated almost every day. Now, the 80% of this data is generally unstructured and 20% is structured. When I say structured, I'm talking about this traditional alphanumeric data, right? Which is, I think all of us are aware of it. Unstructured data would be words, could be pictures, and so on and so forth. Now, obviously, yes, you need far too bigger computing power and storage power to process unstructured data. So this drones took millions and millions of pictures And all these pictures, in fact, in net 4.5 days, these pictures were kind of created. There were patterns created. The pictures were put together. A complete picture was created out of that, and they gave a figure. They gave a figure in their earnings calls in that, look here, we have already done a thorough study of New Orleans, what happened over there. The claims are going to be in the range of this to this, whatever X, Y, Z, whatever figure that spoke about. Just in 4.5 days, they kind of worked it out. And of course, it takes time, right? By the time all the claims come and settle down and all that kind of stuff, it takes about 6 months, 8 months, 9 months, 10 months. So it took about 9 months to get the real data, and it was just 4.3% away from what they actual had predicted. Now, 4.3% is not just, I'm sure the kind of volume that they talk about, it is quite a big, but nobody ever anticipated that. Of course, you can always keep on kind of refurbishing. Nobody wants this, the hurricanes again and again, right? But at the same time, over there, a lot of technologies were used. Drones, definitely, because of, pictures were taken and all that kind of stuff. But apart from that, machine learning algorithms and all that kind of stuff, we'll talk about it as we move further. But within just 4.5 days, they put all these things together, and they came up with what kind of claims are likely to be there, which was just 4.2% or whatever. Now, that was just a beginning of probably what we are, and this is like going to, this became a landmark case for such things in future. And after that, they've been kind of working on it and retuning it for a better one. So, so that's the kind of, stuff which is happening, as a part of, and obviously, yes, I mean, it's just not about industry 2.0, but industry 4.0, but it's all about, the way emerging technologies are helping us out. Nitin just spoke about IoT. I'll just kind of give you a quick perspective, and then we will look at some of these technologies in a little more detailed manner with, some examples and cases as well. So of course, we just spoke about Internet of Things, and we will talk in detail about Internet of Things, but in manufacturing specifically, IoT is going to be the thing for today and for tomorrow as well, even for the day after. But the simple reason is, we deal with machines, and the connected machines are going to be very important for us. It's nothing to do with only. So if you look at cost, quality, and delivery, the three most important measurement of performances that we generally see in manufacturing or any other business venture, IoT certainly reduces your cost. It certainly increases the quality for sure, and we'll talk about it. And certainly, yes, speed. That is the most important thing because everything people want it yesterday, right? So that's where IoT is going to be very important in the future. Augmented reality, which sounds a little misfit. In fact, I was wondering when I started kind of working on this and talking to some people a few months ago. So generally, this virtual and augmented reality is too often considered to be something to do with gaming and so on and so forth, right? But then, yes, it has got a tremendous amount of application in manufacturing as well. And I've got a small example and a case to talk about it, and we will see that as we move further. Cybersecurity, I don't have to dwell much about it. We have been hearing about cyber attacks. We have been hearing about data privacy. There are certain, quite a few data-related, in fact, regulations which are GDPR. A lot of stuff which is happening all over the world. And yes, I mean, your data is extremely important for yourself. And what is more important? So definitely, yes, your data security is utmost important. But somebody burgeoning up your data by hacking your systems and all is absolutely. In fact, there was this news that I read a few days ago, a couple of months ago, and that was a shocker for me. Indian Railways system was hacked, and this is in open domain available, in public domain available. Indian Railway system, IRTCT, right? And it was hacked by some Chinese hackers. They created exactly similar kind of site. They sold tickets and they made money out of it, and people traveled on those tickets, and people didn't know for a while about all this. Now that's quite a bit of thing, and that's the reason that all those things, whether IoT, augmented reality, machine learning, artificial, whatever that you do, if you don't fix cybersecurity, I think it's going to be definitely an issue for us. Then comes cloud computing. I just mentioned a couple of things about cloud, and we will talk a little more about cloud, exactly how cloud is helping us. But yes, apart from storage, in fact, Mr. Sangani just spoke about on-prem versus cloud in his initial remarks. And so cloud, one is definitely a storage, but the thing that I just spoke about, a while ago, that how am I going to afford this? Cloud has an answer over there, because then your entire proposition become far too cheaper compared to what you otherwise would have paid. And we will discuss that in a little more detail later. Artificial intelligence, yes, we're going to be talking about it in much more depth, after this slide. And of course, machine learning. Machine learning, in a way, is a subset of artificial intelligence, because ultimately, artificial intelligence is more of a global umbrella, and it encompasses almost, everything that we generally speak about. It's basically a very generic word which is used. I mean, it doesn't have a specific. Of course, you can talk about definition of AI and stuff like that. But yeah, machine learning is something which is very, very close to my heart. I have been extremely passionate about machine learning, and maybe you will see probably this particular presentation would be little, lopsided towards machine learning, because it is rampant use. Whether it's augmented vehicles, you talk of NASA's ventures, ISRO, everywhere, wherever the data is processed, machine learning happens to be around. And that's where I really very, very, in fact, initially I was influenced and impressed, but now I feel that machine learning is something. In fact, the other day there was very interesting stuff which was happening. There was this Australian Open, the tennis match, and at a certain point, it was predicted, and so-called AI or machine learning algorithm predicted that Medvedev is going to win. The probability of Medvedev winning was 96%, but apparently then later, the entire algorithm. So that is what is very important. Somebody said, I think Benjamin Disraeli, right? There are three kind of lies: lies, damn lies, and statistics. And of course, statistics is the basis of machine learning. But then there's a corollary to that, which basically says that statistics never talk lies. Liars use statistics, to prove their point. So you have to be really, really careful. And so far as this particular instance that I'm telling you, Rafael Nadal has got formidable, performance record. Almost 90.5% of the matches on hard court he has been winning in the last about 15 months. With that kind of formidable record, somebody shouldn't have been predicted that there are chances that he would lose the match by some 4% or whatever. Anyway, the point is, machine learning is extremely powerful tool, but again, same thing, who is using, how it has been used, that is very important. And that's where it can go either which way. Robotic process automation, Mr. Khorakiwala spoke about it, Uday spoke about it. I think it is everywhere now. It is everywhere. The cognitive bots versus the traditional bots. Of course, we started with traditional bots, and it is touching us almost several times a day. Every time you go to Amazon or any other, open any site, and suddenly they the chatbot will pop up and say, may I help you, or whatever. So I think it's no more emerging to me, right? But yes, cognitive bots are emerging to me, because every time a question is asked and an answer is given and the answer is not correct, and that's why machine learning backs up robotic process automation, and it helps the bots to learn. So first time, if the bot gets a wrong answer, the bot learns, and next time it gives the correct answer. And that's where ML powers robotic process automation. So that's where traditional bots are very simple. They were kind of in isolation, were made pretty okay. But when machine learning jumped into that, it became extremely powerful tool, to use for several things, because it just learns and it keeps on answering. Every time the accuracy increases. The more complicated questions you ask, the more intelligent the entire thing becomes. Similarly, when Watson versus Kasparov, 1997, the famous game happened. First time, a couple of times, the Deep Blue lost. But the third time onwards, it just kept on winning, because every time it was losing, it was learning, from the failures. And that's why artificial intelligence is all about learning from the failures or whatever that you call it. So that's artificially when you do it, when the machine does it. Yes. And of course, additive manufacturing. We've been talking a lot about additive manufacturing. Somehow it has not taken shape the way it should be, but I would urge and appeal to all our friends from manufacturing. I think this is something that one must kind of take it very, very seriously, because here is where again the future is going to be there. So let's go through some of these technologies as we move further. Obviously, yes, when it comes to manufacturing, nothing can be bigger than IoT, Internet of Things. So just to kind of give you a small example, and I just give you one example of Coke and Walmart. There are several such examples. I mean, for example, if you're wearing a wearable, device, maybe a smart watch or whatever. What happens is, I'm just giving some example here, that this man is wearing a wearable, and the watch notices that the temperature is about 102 degrees. Okay, and automatically, of course, so the moment, so the program is such that it says if the temperature crosses say 99 degrees Celsius Fahrenheit, immediately there should be a message which basically says that, shall I call up the hospital and take an appointment of a doctor? And if the guy is agreed, definitely, you just press the button and appointment is taken. Now, these are the things which are happening through, quite a few of the wearable devices. In fact, there's a Finnish company called Sunto, which makes, wearable watches. They are one of the best ones in the space, and they have included several things. So they also take, if you kind of climb on the, maybe in Himalayas, for example, about 17,000, 18,000, 19,000 feet. So it takes that into consideration as well. With that, what kind of blood pressure that you will have. So several things, because they have made that particular device for trackers, those who go for trekkings, right? So the mountaineers. So likewise, they are doing several things. The wearable devices are really creating a lot of. In fact, there are a lot of companies which are into health, right? And they also kind of give wearable devices, which basically talks about. I mean, we all do that, right? Number of steps taken, and I'm going to be talking about this as well again little later in a very different perspective. But yeah, this is basically Internet of Things. That's what Internet of Things matters a lot. So essentially, it's it's a network of physical objects that are able to collect data. I'm trying to make it very simple for of course, most of you would know IoT, but those who probably have heard about IoT, but what exactly does it mean? Kind of layman's term. It's about it just your physical things through sensors are kind of network with each other, and they collect and share data. And if need be, depending upon the way they are programmed, they kind of process the data and then convey that data. That's about it. L&T, Larsen and Toubro, the construction division, they did a fantastic thing a couple of years ago, just before the COVID. They retrofitted all their 400, 500 construction equipments all over India, all over the country by sensors. They use a very powerful IoT network. And these sensors were not only talking about, of course, one is definitely is what kind of condition and everything. But apart from that, the kind of load that that particular, there could be road builders, there could be JCBs and all kind of construction equipments. So how to move construction equipment from where to where, what is the capacity that we have, how many of them not working, how many of them are working, because all the 400, 500 equipments were lying all over the country because they have the sites all over the place. So they have started controlling, and that actually helped them a lot. So that may not fetch any direct revenue for sure, but definitely huge amount of impact on the bottom line in terms of optimizing resources, right? So that's a fantastic stuff, which this company called L&T Next, which is a captive company for Larsen & Toubro for their digitization purpose, which their CEO, Mr. Subramaniam, has started. In fact, he's the man behind that particular venture. So terrific application of IoT, and I mean this so that's another question, that I don't have my equipments which are like state of the art. So what I do, all these equipments that Larsen & Toubro did, they are about 10 years old, 15 years old, 20 years old, but that doesn't matter, right? Because all were so fabulously retrofitted, all the sensors. So they have actually managed. So don't have to really wait for a new thing to come so that you can change it. I mean, people, there's a word, which I often hear called legacy modernization. So how do I modernize the legacy? And there's an answer for everything. Every question is born with an answer, and that's what I believe. So that legacy modernization is something which is very important in this particular case, and they did it fabulously well. So that's about IoT. Let's move further. Cloud computing. I just spoke about it a while ago. I'm not going to spend too much of time on this because we'll be again talking about it in terms of. So basically, use of remote servers. So servers capacity used to be always a problem. There's a money involved in that, and of course all these were capital equipment. So you have to work for those capitalization, the equipments and so on and so forth, right? So so in this particular case, it's very simple. You really don't have to buy. Everything is rented. Everything is available on rent. Okay. So the space, whatever space that you want, you don't really have to buy a huge server and invest so much of money. So what used to happen good old days is that you would put in so much of money in that, and within about 2-3 years they say that no, it's gone, now you can't, because the new programs which have come requires more processing power, more computing capacity, and more storage. So of course you have to scrap or maybe upgrade and keep on doing it, right? So there's a money involved in that as well. So that's the reason that cloud, and again, it's not only about storage, it's the tools that you're using for computing purpose. And that's where I think one should be focusing more on that. Currently, of course, there are Azure, which is Microsoft, AWS, IBM. In fact, when I do things on image, particularly images, because images is something which you just can't store. I hook up to my cloud space on AWS, and there's millions and millions of images available. So I do whenever I do, and images are particularly used. I'll tell you where exactly they're used. In human resources perspective, I'll tell you your face expressions, basically emotion recognition and facial expressions, while you're being interviewed, and this is algorithm that we're currently developing as a part of our venture, that when a tricky question is asked, if there is any change on your face, that is immediately noticed by this particular algorithm, and they say that there is a need to probe further, right? Because sometimes I wouldn't say fake answers, but yeah, probably there could be inappropriate answers and so on and so forth. And employee engagement, there's a lot of other things. So when I do this kind of stuff, I really don't have so much of data with me, humanly impossible. I hook up to my AWS server and just kind of use their services, and that's about it. So it's simple, I mean, a small firm like ours can also do something which even otherwise a big firm could have done. Otherwise, I think that is the beauty of it, and that's where, as Mr. Sanghani said, it is very, very relevant to SMEs and MSMEs, because we should not be feeling that just because I can't afford and that is not my capacity to buy those kind of things, I won't do it. Well, I think cloud has kind of taken that entire thing away. I think that's the biggest thing that cloud has given to us. So this is augmented reality. I just spoke about augmented reality. The virtual reality, augmented reality, because of several games, and our kids keep on kind of moving with their Pokemon Go or whatever, we feel that it is more to do with enjoyment and entertainment. And so, yes, it does, definitely, nobody agrees. But there is this nice case that I read, and in fact, of course, this is not India, it's currently happening in Germany. Germany is a place where big time manufacturing, artificial intelligence application manufacturing happening, right? Because of course, everyone knows German manufacturing is supposed to be one of the best, and those guys are really, really picking up very, very fast. Of course, Germany and the Scandinavian countries. Now, in this particular case, I've given a small example where the device that you are having, it's an iPad or whatever device that you have, a Samsung Galaxy or whatever, you can probably see exactly what is happening. But more than that, it also superimposes, and that is very important. It superimposes the digital information, the data about that particular instrument that you are seeing, right? So how much, and that's the beauty of it. I think that's where augmented reality would definitely be of great help in basically preventive maintenance and maintenance related areas. It will be of great help for all the manufacturing, those who are in manufacturing spaces. Another reason, if you look at top 10 applications, why we are focusing so much of manufacturing, unfortunately, and very, very unfortunate, if you look at top 10 implementations of artificial intelligence, right, almost 9 of them would be services. There would be Alphabet, which is Google over there. There would be IBM, which will be talking about their Watson, and now there would be Amazon, and unfortunately, and obviously all of them are probably more focused on services, but manufacturing is only thing is they're not getting publicity. That's the problem, because there's so many things are happening, but unfortunately we don't get to know about it. We will definitely talk about a couple of them for sure today. So augmented reality currently is not very popular, but I see a huge future for augmented reality as we move further in coming years. Okay, let's move further. Additive manufacturing. Now I have a very fantastic. So this is also known as 3D printing or 3-dimensional printing. Now unfortunately, again, since 2016, 15, 17, we've been talking about 3D printing. Never took the kind of place, or it's been always talked about. Yeah, there were some people trying POCs and other things are happening. I just give you a small example how 3D, basically additive manufacturing helped NASA. In one of these ventures, they and NASA has people who go and kind of stay in Skylabs right over there. They stay there for a while and then they come back because a lot of experiments are being kind of carried forward and all. So apparently there was some part which was kind of stopped working in the lab, and they wanted that particular part. And again, if you have to send another rocket from here kind of to reach out to them, would be definitely ultra expensive proposition. So what they did is they carried the 3D printer and all the designs and whatever is needed, they carried with them over there. And that particular part was printed by the astronauts sitting in the lab, and then started using it usually. So that became a normal. That was basically an advent. But after that, yes, every time, to certain extent, of course, depending upon the size. But that's what they have kept a 3D printer in lab, and whenever there is a need, those kind of things are produced rather than kind of carrying it to the small things you're able to carry. Similarly, in manufacturing, I think this is going to be very key thing, because for small parts, your downtime of your multi-spindle, your Crichton, whatever machine that you have in your premises, at times is down, and downtime actually hurts the most, because your entire manufacturing process gets halted if it's a bottleneck operation. And I think that is where you must seriously consider. Again, one would wonder whether can I afford this kind of huge things. We will talk about it a little later, because yes, affordability is also an issue, because ultimately it's it's a financial proposition, right? Payback time. And just for maybe 3-4 parts a year or 10 parts a year, why should I buy the entire elephant? So that's an issue. So we'll talk about it later. So this is basically additive manufacturing. Now my, of course, favorite artificial intelligence, with what exactly does it do, right? So this is basically more of a simply, I can call it, well, demystifying, simplification, and whatever. I can make an attempt. So essentially, artificial intelligence has 3 parts. One is symbolic learning, which means robotics and computer vision. It has expert systems, and it has my favorite, machine learning. So let's kind of spend some time on this, and then we will talk about machine learning in a little more detail way, right? So let's understand first what exactly robotics we all know about it. So there is nothing much that we need to really talk about it. But if you kind of draw up a vertical axis, right? The symbolic learning and robotics is all about doing, and machine learning is all about learning, right? And when both of them kind of come together, for example, the learning robots. Now that's going to be the cognitive robots, as they call it. These robots are backed by the machine learning algorithms. So every time when they do something, if the action is wrong, the machine learning algorithms teach them that this was wrong, and whatever you have learned new is the correct, and please act accordingly. So that's really powering, and that is the reason when the entire, so robots has been around for like umpteen years, right? We've been hearing about robots in Japan on manufacturing shop floors, on the assembly lines for years and years together. And there are several. If you look at some of the BMW factories in Germany, and some of the Ferrari factories in Italy, there are a lot of robots which are used. In Toulouse, the assembly line of Airbus has got a lot of robots. But all these robots are programmed robots, right? Now that machine learning has kind of jumped into it, it has become cognitive, and that's where, of course, yes, one would wonder, and there are debates and debates and debates about what will happen to human beings ultimately. And I don't want to get into that at this point in time, but robots are now learning on their own, and they have started kind of talking about it. So if you look at symbolic learning, it is more driven by the process, because of course they're more pushed by the process, whereas machine learning is all about data, right? So it collects the data, and accordingly and as I said, data could be anything. It could be alpha, numeric, pictures, voice, words, whatever that you can think is data. Good old days we used to think data is only about numbers, then probably came alphabets, and then after that, of course, now data is everything that you can think of. Okay, so if you look at, quickly look at this, robotics, we know about it. Computer expert system, Siri, Corona, Cortana, Alexa is there. But apart from that, there are quite a few other expert system, that are there. For example, there's an expert system called Cadet, which is one of the best expert systems that identify cancer at a very, very early stage, right? There is another expert system called Dendral, which is basically I'm sure Mr. Khorakiwala would be more conversant with this kind of stuff than any one of us. But it does chemical analysis of to predict the molecular structure of the given elements. So likewise, there are several expert systems which are being developed, and they're just mind-boggling stuff. In fact, I remember to have read one very interesting case, and that's about cancer. And I'll tell you how cross-pollination happens over there, right? This is a very interesting study, guys. So what happens is, there's a group of data scientists, and they wanted to work on cancer. What is exactly causing cancer is something that they wanted to work. Now, of course, you have oncologists and you have a lot of experts, doctors who are working on it, and they know definitely much better. But the data scientists they knew nothing of oncology. They just knew the data, and millions of cancer patients' data was analyzed by these guys. And they said that one conclusion that we can make, that almost 82% of cancer patients were acidic, and they said that acidity possibly is one of the most important cause of cancer. Of course, there would be genetic and several things, right? I don't want to get into the medical side of the story, but but acidic body is actually, and there could be some scientific reasons. I don't want to get into that. I just want to talk about only data. And of course, then after that, there were several things which were done. So likewise, expert systems are developed basis a lot of data, and these systems, in fact, most of us are unaware of it because we are not specialized in that area. But these systems are really, really helping, medical sciences, chemical, several areas, manufacturing, several areas. The expert systems are they're expensive as well. Okay, and finally, machine learning, which is categorized into classical, reinforcement, and deep learning. Now, let's not get too much into what is classical, what is reinforcement. Deep learning is neural networks, and again, since we are talking about demystifying, I will not further make it complicated by talking about how neural nets are run and all that kind of stuff. That's a little deep. And there's a lot of mathematics, a lot of linear algebra, differential calculus, and coordinate geometry involved in that. So, well, I would keep it aside. I'm not talk much about it. But it is very intriguing to see how exactly the entire thing works. So we can have a quick look at it. So let's first understand what is machine in machine learning. Okay. So the machine learning, the term was coined by Arthur Samuel, one of the IBM executives, way back in 1957. So machine learning, there's nothing new again. It was just around the word artificial intelligence was coined. Around the same time, machine learning was coined. And why machine? Because computers were called machine at that point in time. IBM, that M stands for machine. We all of us are aware of it. Turing machines. I'm sure some of you would have seen this famous movie called Imitation Game, based on Alan Turing's life. The entire computer, as we call it now, was called machine by that point in time. So machine learning is basically nothing but computer learning. That's it. Unfortunately, machine is a very manufacturing centric word, and one wonders, machine learning, what is machine learning doing in services and so on and so forth. So machine learning refers to process of learning, begins with an observation or data. So basically, it collects lots and lots of data, understand the data patterns, okay, and then learns automatically without human intervention and assistance. And I'll just give you a small example about very, very a rudimentary example though, but I'll just give you a small example of machine learning. So basically, I said machine learn for patterns. Now, how does your mailbox separate junk mail from regular mails, right? So your mailbox receives all kind of, as they call it, ham and spam, because that is colloquially it is used. So all mails kind of land into your inbox, and then there is this machine learning algorithm which works, right? It picks up. So what happens is, and how does it learn? And that's where the demystification that Mr. Nandani had told me about. So that's why I wanted to kind of work upon it. So what machine says is, okay, fine, this particular mail that I have received, in the subject, if there are words like offer, act, now, save percentage, sale, festive season, or something like that, So all these words are basically, so if you look at say 100 spam mails, okay, almost 80 or 90% of the spam mails would have had these words. So, and machine has been taught, machine learns that once you have these words, it is spam. If you don't have these words, it is ham. And it starts kind of segregating on that. However, having said this, still, sometimes you see that some of your important mail, they land in your junk folder, and some of your not so important mail or other spam mails, they land in your regular. Why does it happen? That happens, okay, and that refers to the evaluation criteria, that how does efficiency of machine learning algorithm should be evaluated. So there's a criteria called accuracy. Now that accuracy goes for a little toss because, but cognitive algorithms learn that as well. So once they make mistake, and if you pick up that mail from your regular inbox and drop it in your junk box, machine gets this alert that this mail is kind of moved, which means that there's something wrong with that machine, that particular mail. And next time, similar mail, it will never, get into, mailbox. Some other mail can get into your regular mailbox, but the similar kind of mail will never get into, because machine has learned. So long story short, machine learns like that. It basically learns from the patterns, and the patterns are basically from what kind of, for in this particular case, words are there. Likewise, same thing about sports analytics. In fact, I remember Lionel Messi, he was almost, they say that he was kind of neutralized in one particular season, because what they did is, in fact, while they train, they use sensors on their body. Even in the US, a lot of people who, a lot of players who play baseball, American football, as well as NBA, they put sensors on their body. And after that, the heat map is created, how they move across the court. Okay. So, the Messi's heat map was created. And then they came up with this conclusion that, Messi is a left footer, right? So just outside the box, to some 30 degrees to whatever, they had calculated this, Messi becomes extremely dangerous. And if that is where, if he goes, there are very high chances that either he can give an assist or he can score a goal. And that's where, they told their, fullbacks, sure that the ball doesn't get into that zone, because if you go there, he's going to, create havoc. And that's where, they kind of acted against. I mean, well, there's a huge case study about that. And then again, these guys studied that, and there's several things happen. I don't want to get into that, but the pattern was studied. Okay. So sports analytics is another one, which is a huge amount of machine learning algorithms are happening, and they're kind of coming up with a lot of advisories. Of course, ultimately it has to be used by someone, right? So that's how it is used. So this is basically it is a small thing. I don't want to kind of overwhelm you with this particular graph or the graphic, and I don't want to kind of make it very complicated, but just kind of to give you a perspective. Machine learning has got so many different tools, right? And these tools are used, for example, so I have encircled classification. Now classification is when the output is yes and no, right? When there's a dichotomous output. For example, I spoke about mail, right? Ham and Sam. Okay. In fact, in HR, we have attrition, right? So people quit or people don't quit, and we do predict what are the chances of people quitting, and that's where these classification algorithms are used. However, regression algorithms are a little different, right? Regression algorithms, when you have a continuous scale. So what is the performance, for example? Performance is not yes and no. Performance is in between also, right? And sometimes performance will have 5 or 6 or 7 different shades of it. So if it is not yes and no, it becomes a regression, and so on and so forth. So likewise, there are several things. I don't want to get into that, but this is mind-boggling. That you have so many tools which are. In fact, I'll tell you, since we're talking of yes and no, I'll give you another example here of machine learning. Again, I'll go back to cancer. So there was this group of data scientists who were supporting, and how cross-pollination happens. This is very important, guys. That's what I want to tell you. So these guys studied several cancer patients over a period of time, and they wanted to basically see the shelf life, in the sense that that's why this particular analysis in machine learning is called survival failure analysis, or other survival analysis. Failure is a little bad word, not bad as a negative word. That's why they took it off. So they kept it survival analysis. And they found out that, and in fact, they were able to predict, of course, all variables is given, but they were able to predict that if a cancer patient, whether he or she will live or live for how long. So, how many years, how many months, how many days, and so on and so forth. That much precision that they had acquired, because a lot of data, and they use this very famous, in fact, the guy who actually invented Cox regression, unfortunately, he passed away, a couple of weeks ago. Very famous statistician. So, Cox regression is used, and that's where, machine learning is used for the. So what we, a few of our HR guys, what they did is say, okay, fine. If cancer is talking about survival and failure, we will convert that survival and failure with attrition and non-attrition. So now in HR, we have started predicting that when would you leave? Whether you will leave or not leave is a classification algorithm. But when would you leave? Would you stay with us for 2 years or 3 years or 10 years? Is something which has been kind of worked around. Exactly the same algorithm which was used for cancer patients now is used for HR. So that's how the cross-pollination happen in, this kind of thing. So it's a very interesting field. In fact, I'm really, really passionate about it, and I keep on kind of working on. So this is basically a quick perspective on how it works. A little complicated. I'm not going to give too much of time in this, but since again I have to kind of simplify it. So historical data plus live data is used. Okay, then data cleaning in India, data discipline is a problem, very big problem. So that's where you need to really use some cleaning, and again machine learning gives you cleaning algorithms. So you clean the data, then there's something called feature engineering, which is basically features are variables. So different variables, how they are manipulation is not a negative word in this sense. Manipulation is a positive. So it is manipulated, right? Which means sometimes you kind of get two features together and create another feature. I'll give you an HR example here. For example, there are two features available. What are the two features available? How many companies that you work for and how many years that you work for. Okay. So I can combine these two features and say, okay, how many years per company that you work for. And that's a third feature, which is feature engineering. Then a part of that data is taken and that is used. So when I said about patterns, right? Now machine learning needs to know what are the patterns, and the training data actually teaches machine learning what are the patterns. Okay. Then so that's where this particular thing happened. Then they create a test model. Then they evaluate, and I just told you about that accuracy of that model. Then the select model, and ultimately they use it for prescription. Okay, so I have to just quickly tell you what is this pattern recognition. Here it is happened. So if I get this much of data, okay, I divide that data into two, right? A part of that data I keep it as a test, test data, and a part of that data I take as train data, and I use it, for training. And here is, so I'm not getting too much into cross validation because they kind of use a lot of iterations here, but on the basis of this train. So this is where the training of, or the rather learning happens. This is where the patterns are studied, which means that those 3 or 4 or 5 or 6 words in the ham mail or a spam mail are there. It is taught. And then it is tested on a part of that data, right? And if it is good, then only it is implemented. So in short, this is what machine learning is all about. Okay. This small, perspective on how machine learning can be used for manufacturing. Okay, so I just spoke to you about classification. So predictive maintenance, for example, you can use multi-class classification. Okay, possible outcomes here would be a machine health. How good or bad the machine is. What are the risk levels? What are the possible reasons for malfunctioning, and when will it malfunction? In fact, survival analysis, as I told you, cancer patients is also used, for over here, right? And it basically talks about RUL, remaining useful life. So if you're working on a particular machine or using a particular tool in, on your any of the tooling machines that you have, what is the remaining useful life for that particular tool that you have, and how to increase the life? What are the? Of course, you all know everything, but when you have too many machines with you, how do you do that, right? So that is something which is how many days, how many cycles will it last for? So that is something which is taken over here. These are few HR examples. I'll go a little fast. Starbucks, of course, we all know. Container Stores, Whole Foods, and Home Depot. These three companies are US based. Container Store is a very small, a couple of $1 billion company, but I really love it because of the creativity. Whole Foods is more of an eco kind of thing, and Home Depot is a very, it's not IKEA types, but in the same kind of space. Okay, so what they did is they had so they were basically wanted to see what is it that increases their footfall, and this is pre-COVID data, by the way. After that, I've not seen it, and how they retain employees. So what they did, exactly the way we studied machine learning, guys, they picked up the best performing stores. Okay, and what is so good about those stores, and the data said that the best performing stores in terms of footfall and retention of employees, that those particular stores had employees who were 18 to 24 years. In case of Asia, it was 26 and 28, but in US and Europe, it was 18 to 24. Both genders, males and females, low job security needs and high lifestyle needs. And those are the guys who basically made this possible. And the same similar study was done by a container store, and the answer were very different. It was 30 to 50 years old females, not males, in order to make container store more successful. For Whole Foods, it was 20 to 30 years old males and females. And for Home Depot, active retirees. In fact, when I visited a couple of Home Depot stores, they had 55 plus guys who were basically kind of working over there. So that's how this is very interesting. A big case study. I don't want to get too much of it, but I just want to tell you that they basically studied this in order to ensure success in terms of footfall as well as, and it is given that footfall is there, then definitely I'm sorry here. I'll just quickly take you through this. These are the things that we generally often see. It's a very detailed slide, but still, we do sentiment analytics as well as emotional analytics, and too often we pick up data from all the. So just case in point, I'll tell you. Now there is a lot of data protection law which is preventing, but otherwise, sure, looking at the comments, the likes, and the posts that you do on all these social media instruments, there are tools that can actually prepare your personality and as a customer, and actually they can get deep into your so what exactly would you do given a choice, and what kind of goods that you, of course everything for commercial purpose, and what kind of ad should be shown to you. Everything is decided by mere this sentiment analytics which is done, or profiling which is done by machine learning algorithms, and this is essentially for the social media. Recommendation engine, I will not talk much about it. Amazon, you are aware of it. Google, of course, autonomous car, because self-driving car for Google is something which is in Tesla both, right? That is again driven by completely IoT and sensors, which we are aware of it. I will not stock market predictions now. That is something. So I remember there's a friend of mine, econometrician, and he used to prepare lots of such models for some of his clients on NASDAQ and NYSE. And he used to say, he's a very eminent economist in India, and he used to say that I give them something, they make money, but I don't believe that they're making money. I mean, the guys who are actually working on this like to win. But yeah, there are a lot of econometric models which are prepared for prediction of stock markets. But someone rightly said, someone who can predict stock markets and crude prices is the one who is going to be probably the richest guy in future. Amit is asking any example of sentiment analytics too. Amit, I'll answer your question towards the end, because let me finish this and I'll come back to you. Sentiment analytics, I do it, as for my HR clients as well, and I'll tell you exactly what we do. It's very important. It's very important. Then of course healthcare, which is, I just spoke about a couple of expert systems such as Dendral and Carrot, which are used for cancer detection and stuff like that. So a huge amount of application in medical sciences. Banking, fraud detection, very, very prevalent. Okay. Ola, Uber, dynamic pricing, we all aware of it, completely driven by machine learning algorithms. And of course credit cards, where who should be given cards, again a fraud detection on cards and so on and so forth. So there are several such things. In fact, time would be insufficient for me if I keep on kind of talking about it. But I thought I'll just get on to, we just have another 10 minutes left, I guess. So I'll just deep dive into. So this is again IoT, but very interesting case study, guys. I just loved it, because when I spoke to this particular person who worked on it, very passionate about it. So this is an automotive manufacturing company, and the objective was to reduce the warranty claims. So they are manufacturing trucks, and all the trucks are fitted by sensors. Some of them were retrofitted, as I told you about L&T a little earlier. But when they started producing it with the sensors itself. So these trucks are plying on the roads of United States, and they keep on sending the information. Now, this is very interesting. The information related to their clutch plates, the gear oil, the brake oil, what kind of everything, what is happening in differential, what is happening in engine, every tire, everything is being kind of sent on cloud, and from cloud it is collected to a command, a SOC as they call it, systems operating center, and system operating centers keep on kind of churning this data. Okay, and that's why these machine learning algorithms are used, and this data yields lot of indicators. Okay, so how does it and of course once you know exactly what is happening in the truck, it is communicated to the respective truck. Now, where is this warranty claims and other things came in? Of course, otherwise also it's a very formidable tool. But what exactly happened is when the truck is bought, okay, there's a warranty for 3 years, comprehensive warranty, 3 years, 4 years, 2 years, 5 years, whatever. Okay, and as a part of that, you're supposed to be going back to the the company and change your oil or some parts and so on and so forth. Like in the US, you do that. Now, this guy said that, okay, fine. Now we won't give you a schedule. You don't have to come back to us till the time you don't get a message on your mobile. And the moment a gear oil is reaching to a critical level, they get a message on their mobile that your oil is reaching to a critical level. Please come to one of our service centers and get it filled up. Right? That's a part of. So otherwise, there's to over-engineer everything, and most of the companies do that. But there are millions of dollars saved sheer by this application. In fact, about 6 or 7 months or 8 months, the payback time, whatever they invested in this was recovered, and after that it was all so such a fabulous. And after that they kind of told, okay, fine, for every other thing we can offer you this, and that's how this particular company did a killing by introducing. Of course, others benchmarked it earlier, but very interesting case study for automotive companies. Okay, this is basically a predictive maintenance, another sensor fitted tool. So again, IoT and machine learning both together. You can just have a look at these pictures. What is happening is the tools which are using in that tooling area, and this is basically just a schematic representation of it, but it keeps on kind of getting damaged again and again. You can see what is happening here, right? And it basically gives so huge amount of rework and rejection because of the tools are faulty, the tools need to be changed, and again you lose so much of time and money on that, right? Efforts as well. So they use sensor fitted tools which well in advance said that, okay, fine, this tool, the life of this tool, and that's where I showed you one graph, right? Usable time left. So they said that the usable time left for this particular tool is now about 6 months or 2 months or 3 months or few days, and that's the time you can go. So you don't really have to waste. So you don't over engineer in the sense that the tool is working and still you don't replace it. At the same time, use the faulty tool to kind of bugger up the product as well. So a lot of rework and rejection was saved because of this. Now I'm going to talk something which is very exciting and which is absolutely latest, I must say, and something called digital twins. Okay, it's a living model that drives the business outcomes. So a couple of years people have been talking about digital twins, but the rate at which technologies are kind of getting commoditized and popularized all over the world, I don't think it will be just a matter of time that digital twins come to India. Oh, sorry. So my bad. Once I'll just first explain the digital twins. So what generally happens is, suppose you have a machine over here. Okay, this is the actual device, actual machine that you have. Now, obviously, yes, again fitted with sensors, and whatever that whatever is happening in that particular machine, the data is supplied and a replica of that. Now, there are two kind of digital twins, right? There's a database digital twin, and there is a physical digital twin, which is based on virtual reality, and that's where virtual reality comes into picture. But that is freakingly expensive. So when NASA does it, for example, a digital twin of a rocket, they do a physical. But most of the times in manufacturing, it is a database digital twin. And what is a database digital twin? It basically nothing but simulates the same data as the actual machine is producing. All kind of data which is there with the machine, right? And this data is then later, these algorithms are processed, and after that, you come up with how long will it work, and so on and so forth, right? So that's how the entire um, thing is, and it goes back to actual device. So this is basically, so I'll just give you a small example in terms of how is it exactly worked. So this is a bridge in Norway. Okay, so this is the actual bridge, and they created a digital twin of the bridge, and they fitted the sensors. And what happened is on 6th of April to the last year, okay, the digital twin said that there's something happening right over here, and immediately do something, otherwise next 6 months, next few days, the bridge will collapse. And needless to say, they took immediate action and they corrected it. So that's how digital twins help you. Okay, so this is another case of connected cows. I'll just take a couple of minutes. It's very interesting. There was a cow farm, and this is basically for supply chain problem of cow milk. What they did is this cows were fitted by variables. Okay, and the stepping style was taken. So what happens is, this is a little detailed study, but I'll just cut it short because we don't have much time left. The variable devices were basically, taking note of the stepping style, because what happens is when the cow comes on heat, the farmer has to go and artificially inseminate the cow. That's how the entire thing happens in the US, right? So you don't know when the cow is coming to heat. So they did a lot of studies, some animal husbandry people, some scientists and all that guys. And they said that, okay, fine. When the cow comes on, heat, a few hours before that, the stepping style changes. So the command center gets to know that the stepping style changes. They'll immediately inform farmer, then farmer goes and inseminate. When you have 500 cows and 1,000 cows, how do you do that? Right. So that's how the entire thing happened. Mukesh, you have a question. Let me finish and then we will come back to your question. Just give me a moment. I think we have just a couple of cases left. So this is your answer for how expensive the entire stuff. The answer is equipment as a service. So this is a new thing which has started coming up. OEM manufacturer actually prepares this machine engines or whatever that you have, okay? And then the reinsurance companies are actually giving it to the client on a rental basis. You don't have to buy the equipment, right? You just have to pay rent for that. And to the reinsurance company, like Munich Re in Germany, they do that very often. India, it's coming very soon. I've been hearing about it. So you don't have to buy the equipment, you just pay the rent, use it, and if at all, and the data goes to the OEM manufacturer. So whenever there is something, need to be done, the OEM manufacturer will come and do the maintenance, right? You don't have to pay for the maintenance. You're just paying rent to the reinsurance company. That's it. And that's not much. So very expensive equipments can be easily used, by you. And that is it. So what are the benefits? Productivity, efficiency, cost optimization, customer satisfaction, safety, new opportunities, all those things are there. So I would like to conclude on a very, one of my favorite, of course, Klaus Schwab, we all know, your founder and executive chairman of World Economic Forum. He said, in the new world, it is not the big fish which is the small fish. It's the fast fish which is the slow fish. And then that's where I have the, corollary to that. Charles Darwin spoke about survival of the fittest. And I say survival of the fastest. So sooner you do it, better for you. Thank you so much and there are quite a few queries and we'll talk about it, but it's been really, really pleasure.
Thank you, Dr. Save. This was extremely insightful, very, very helpful. And I think we've tried to pack in quite a lot, into this session. So what I would like to request you is if you could answer Mukesh's question, that is to do with any example, if you could dwell a little bit on the cost. Of any example. I think you already sort of mentioned one example, but maybe if there's any example that comes to your attention where you've used in any MSME, IoT and AI technologies, what are some of the benefits you observed and how much was the initial investment that they had to make?
So definitely, that's why Uday, my second last slide spoke about it. I knew this question was coming. Because fitting sensors and customizing it. So there are quite a few companies. Siemens does it. I mean, I can name quite a few. Bosch does it. All those companies are doing it. They continuously work on this. POCs are on. But my best bet would be on, the equipment as a service, which is just starting. Munich Re has started, and Germany, it is big time happening. In India, they have started working on it, and very soon it will come. So Mukesh and others, just to kind of answer your question, you can hold your horses for maybe a few more months. You don't have to really buy. And I would highly recommend we close. SMEs and MSMEs should not get into buying because, that's a huge capital cost, for us. So I think just hold your horses, and I'm in touch with Mr. Sangani. The moment I get to know that something is happening here, I'll quickly, touch base with him and you can kind of get. But otherwise, it's an expensive proposition. The payback period is anyway, depending upon the proposition, what kind of need, but it's anywhere between maybe over 8 months to a couple of years, depending upon the size of the entire project.
Yeah, and Amit's question, which you said you would certainly take it up at the end of the session, is on
Sentiment.
sentiment analysis, something that I know is very close to you, Dr. Save. So
No, so one, of course, I spoke about in interviews and engagement. So there's one very interesting study that I have for one of the retailers. Again, a pre-COVID study. Post-COVID, people have not been going to the retail. So you know what? People who are entering in the retail stores, the pictures were taken, and while people are exiting out, the pictures were taken, and through the shops, the pictures were taken, and the entire analysis. So the buying experience was actually quantified rather than filling up a form. That was more genuine, because the customer who is contented and a satisfied customer, and the customer is really irate and agitated customer. So that's how these guys used it big time. There's a company called Belk. Unfortunately, they filed Chapter 11, I guess, because of COVID, of course, and a couple of others. They did. Macy's did it for sure. In terms of Macy's used virtual reality also, by the way, but yeah, we use customer analytics, facial and sentiment analytics in employee engagement in HR, as well as interviews and stuff like that. But in retail, it is used big time to see the customer behavior. That is one example I can think of.
yeah. So how wise would it be? There's a question here to invest in AI and ML for MSMEs, considering the costs.
Uh, uh, Mr. Sangari, I'll use your words that you said, the other day. It is not a choice anymore. It is imperative, right? So yes, it is expensive for the time being, but it is getting commoditized very fast. But that is cost side of the story. On in reality,
Need.
I think it is a need now. It is no more a choice, because survival of the fastest.
Yeah, and my recommendation here to all the members on this call is ideally it's best, if you have already embraced digital technology into your business operations or into your manufacturing operations, brilliant. So you've already made a leap start, and you're going to be moving more northwards, upwards in trying to get almost every area of your business digitized. But for those who still have not yet taken the leap, and there are quite a few such organizations, the best is to engage some sort of a consulting firm to come in and do a due diligence activity. Wherever you feel there is a low hanging fruit, wherever you believe from sessions that you've been attending, like the ones today, to get a due diligence done. And at the end of the due diligence, they will give you exactly which technology to use, what platform to use, what is going to be the cost. They'll give you a return on the investment. They'll provide a business case for you, which will make it a lot more easier for you to take that final decision. So this is the first step that you need to do. I mean, don't get overwhelmed, with the number of technologies or the algorithms and what happens at the back end. I think it's very important for you to be able to appreciate that, yes, at the end of the day, it's going to get me a lot more benefit in the way I'm running my operation today. And, it's going to certainly leapfrog into doing it better tomorrow. So I think that's the first step that I would highly recommend all the members on this session to take next. Dr. Save, any final points from you, before I sort of hand it over back to Selby?
No, not at all. I mean, it was a pleasure, and I'm sorry I got a little flown with the the topic, and that's the reason I couldn't manage time well. But like Mr. Khorakiwala said right in the beginning, and exactly that's what Mr. Schwab is also saying. The future is going to be very fast, and it's faster than what you are thinking, right? Exactly the similar kind of thought process Mr. Khorakiwala said, and to end the presentation with Shaw. So great, thank you so much, and it was really pleasure. In fact, yeah, as Ashutosh Pednekar has written there, there's so many use cases that I'll keep talking and we'll not have track of time. So sorry
But
about it.
sure, Ashutosh, your point well taken, and we are taking cognizance of that. So we'll try and work out a session which is longer than today's. Today was more to give you an overview, so that we are able to then take it forward and then have an extended session. And Ashok, your point also noted. We'll certainly come back to you, on your request. So thank you. Thank you, everybody. Thank you for an insightful session, Dr. Savi, once again from the IMC Digital Committee, and really appreciate the time that you have taken in putting together these slides. Very informative, very insightful, and lot of information that you provided that will help number of us. Thank you. Back to you,
Thank you.
Selby.
Thank you, Dr. Save. That was really interesting. Wonderful presentation. I think it's made things very easy for people to understand, I suppose. As we come to the close of this highly knowledgeable session, may I request Mr. Harish Tibrewala, Chairman, IMC Digital Technology Committee, to propose the vote of thanks. Over to you, Mr. Tibrewala.
Thanks, Selby. Uday has already done my job of proposing the vote of thanks. Nonetheless, Dr. Rajesh, it was a very insightful session. You have covered a lot of ground, right from artificial intelligence to AR, VR to robotics. It was a very, very good mix of theory as well as practical. So a lot of interesting case studies. I found that case study on NASA doing a 3D printing in the rocket. I mean, absolutely brilliant. There is no other way you could have got the part to them. So these are really how technologies can power businesses and create huge amount of value. So thank you so much for being with us on behalf of the chamber, on behalf of the participants. Thanks a lot. And as Selby mentioned at the beginning, we'd like the participants to share their feedback with us so we can constantly keep on getting more speakers like Dr. Rajesh to speak to you. Thank you so much, sir.
Thank you so much. Always pleasure.
Thank you.
Please take 2 minutes to just give us your feedback so that we can come up with better and better events. Thank you. Thank you to all participants.